All right, yeah. Okay, so this next section, what we're going to do is we're going to get into the base model setup. So we're going to talk about the different elements that go into a Visum model. What kind of physical elements and demand elements do we need to put into the network, and just talk about all the bits and bobs that are in the model itself and how they relate to other structures that you might be familiar with. So to start out, if you haven't done so already, I believe we sent out a link, Adam. I'm not sure with the example files, but you'll get this TBRPM zip file that should be unloaded, I believe, and then you'll be able to find the 2015 init .version file. And so you'll just have to unzip, make sure you unzip that file, and then you can drag and drop that file into Visum, or you can double click on it or right click and say open with Visum. As far as the model structure goes, it's each one of these objects that we saw in the network editor are basically like different layers that we saw that you can turn on and turn off. Again, when you're building out a new Visum model, the workflow is typically going to be start at the top and kind of work your way down for the most part. If we're working off an existing model, or maybe you're doing a model review or building out a specific scenario, that'd be more or less the same way, right? So you're going to add in some new junctions, then link them together, open up the turns, edit your zones, make sure they're new connectors, and so on and so forth. Each object has its own layer in the network editor, so that gives you the ability to independently apply graphic parameters or filters to them. Like Chayton was saying during the Q&A session, if you have different graphic parameter layout files that you want to overlay, you don't have to load all the graphic parameters from each layout file. You can open up multiple layout files and pick and choose which layers you want to import from that graphic parameter file. Here are some different views that we can look at. So for example, this top view is just looking at the nodes only, right? So we can see just the nodes there, or we can see just the links on the bottom side. You could activate both at the same time. It's not one or the other, but here are some ways that you can visualize your network by turning on and turning off different layers. So starting with the first layer, nodes. What are nodes? Nodes are just the junctions between different facilities that we have in the network. They could be intersections. They could also be merge points or diverge points. So anywhere where two or more facilities come together to meet, it's not necessarily just an intersection or merge. It's also where the cross section of the facility might change. So you might have a facility that goes from 3 lanes to 2 lanes, or maybe it goes from 65 miles an hour to 55 miles per hour, or maybe it goes from not tolled to tolled, or vice versa. And so in this case, anywhere where the facility is changing or merging or diverging from another facility, you're going to have a node. Now, a node can have multiple turns within it, so you don't have to worry about each turning movement having its own set of nodes or anything like that. So if you have 4 or 5 legs coming together to an intersection, that's just one node. Now, if you have something like a divided highway, like we see in this image down below, you'll probably have 2 separate link structures, one for the eastbound, for example, and one for the westbound. But you could also have that divided highway be one node. It just depends on how the model is built out. And a lot of times it depends on how divided those highways are, right? If there's just like a solid stripe, then it'll probably be one link and one set of nodes. But if it's multiple link, or if it's really wide, then it might have different ones. So again, just looking at where else you might have nodes beyond intersections, anywhere where your speed is going to change, or anywhere where the cross section is going to change. So you might have different number of lanes, or the capacity or something like that is going to shift. Road surface types, maybe you have a complete streets section where you have traffic calming and things like that as well that would cause vehicles to slow down. And then the final place you'll see nodes are at the boundaries of your network. So there's going to be the physical network with your nodes and links, and then there's going to be zones and connectors which input and output demand from the network. And those come through nodes. So you're going to see in your network a lot of nodes that are just at the end of a link or something like that that are representing the end of a roadway. You can find specific information about the nodes in the list. So if you right click on nodes, there's a list option and you can see things like what type of node is it? What control type is it using? Where is it located on an XY coordinate system within the projection system you're using? You can also see things like capacity and other things like that in the node list, as well as outputs such as travel times and stuff through the nodes. So you can see delayed travel time, assigned volumes through the nodes, capacity, PRT. So in addition to input values in these lists, you also see outputs. And in the list view, the difference that you're going to notice is that if it is a white box in the list, then it's going to be an input or an editable attribute. And if it's gray, then that's a read only, typically an output or some calculation is happening. We also have, if you have different control types used within the nodes, we have a classified display that will automatically pick up the control type and display it there within the node list. Okay, so that's nodes. Before I go on to links, I'm going to jump into the network editor. And I want to show you just kind of what the node structure looks like. So I'm going to turn off the links and I'm going to turn on the nodes by activating the nodes layer. So I'm going to make sure the white box on the left is highlighted. And then I am going to make sure I have the nodes object selected. And here we can see the nodes are shown as like grayish dots. So if I zoom in on, say, for example, downtown, you can see we have various nodes throughout the network representing various intersections, study intersections, especially along the freeways. You're going to see nodes that maybe don't represent intersections per se, but maybe they're merge or diverge sections of the freeway as well. So each one of these nodes, you can open up the list here and say show list. I'm going to put my nodes list off to the side just so that we can see both of them side by side. Close some of these other windows. So if I want to edit a node, again, there's a few ways that I can go about that. I can left click on the node object and I can see it in the quick view here. And so we can see things like T0 PRT. That's the node level delay. We're not really using that right now. But we can also see things like control types or node names if we'd put in intersection names. And we can also see that information in the nodes list. And so again, here we see some columns that are white representing input values, and then we see grayed out columns representing outputs. Again, this is a cleaned version, so we don't have any assignment, any path assignment saved. So in this case, all the volume PRT, all the private transportation has been zeroed out. So this is zeroed out right now. Another way we can look at the nodes is if we double click on a node, you can actually see that node in a Junction Editor view. So let me find a node that's a little bit more interesting to look at. Maybe this guy right here. So here we have a node in the Junction Editor, and you can see that the nodes can get kind of complicated in terms of what goes on. So you can have multiple links and legs. If you wanted to add more information, you'd come into the Junction Editor and you can add in turn pockets and stuff like that if you wanted to do something like SBA or meso level assignment. So that's how you would edit the nodes specifically, is either through the list view, through the quick view, or double clicking on an individual node and editing it in the Junction Editor. And again, nodes represent not only intersections, but real quick, if I turn on the zone connectors, they also represent entry points into the network. So for example, this node right here is a link that's just going southbound, but we have a node in the middle that is representing a connection to the nearby zone. So they also act as gateways into the actual physical network that we're drawing as well. Okay. Once we have our nodes in place, and these can be imported as well. So if you have some sort of shape files or something like that with the node locations, or OpenStreetMaps data, you can also import nodes for new builds and things like that. Once you have the nodes, you want to link them together to create drivable spaces or available stretches for paths to be able to be found for different modes of transportation. So what links are is any junction between two nodes. They contain physical attributes such as names, facility types, different types of number of lanes, capacities, speeds. And a big one that a lot of people overlook, especially when they're new to Visum, is the transportation systems, making sure that you have different modes allowed or disallowed from utilizing that particular link. So you can open and close links by accessing those transportation systems. They also show output data. So you can also see travel time, both T naught, which is the initial travel time, and then T cur, which is the assigned travel time or the loaded travel time with delays, the level of impedance, as well as any toll values or differences between V naught or V cur, which is the initial speed versus the loaded speed, or the unloaded speed versus the loaded speed. In this particular model, we also have some user-defined attributes that we're going to go through as well. But you can see all this information at the list level as well. If I go back real quick, this is all in the link editor window. And we'll take a look at that in a minute, but you can double click on a link and see this information directly on that sublink segment. But you can see all of the links together in a list in the same way by opening up the links list. And here you can input things like type number, what transportation systems are allowed or disallowed, how many lanes are there, capacities, things like that. So jumping into Visum, let's take a look at some links. So what I'm going to do is I'm going to deactivate my nodes and I'm going to make sure my links are turned on. And again, we have this link bar active. But what we can see is, I just want to turn off that link bar real quick so we can see what the general structure of the links kind of looks like in different areas. So if we look kind of in this downtown area, right, we have some of the major roads coded in. And the links in this case are bi-directional. So each link, depending on which side of the link I hover on, you can see how the arrow shifts. So if there's this link right here, if I hover on the right side, that will show the northbound movement on that link. Similarly, if I hover on the left side, that will show the southbound. So depending on which side I double click on, it will open up this link editor. I'm gonna pull this thing over. There we go. So here we can see I'm looking at the attributes for this northbound link. So we can see it's an undivided arterial based on the link type, and there's a bunch of different types to pick from. And all the link type really does is group together the links so that you can mass edit them. They also have predefined values so that if you're building a new one, you can always assign it and then it should populate with certain presets. But the big thing I want to point out here are the transportation systems, right? So what transportation systems are allowed to run on this particular link? And these are the different modes that are allowed to run on this link. And then those modes are grouped together for the assignment as demand segments. Down below in the basis, this is all the physical attributes of the link segment. Again, just the northbound segment, so we can see how long it is. We can see what the V0 PRT or the unloaded speed is. How many lanes does it have? What capacity does it have? And then if we move over to PRT TSYS, this is the private transportation systems. So these are basically the different modes of transportation. So we have, for private transportation, we have HOV, SOV, and truck traffic. And so we can see their initial speeds by transportation system. We can see their initial travel time versus their loaded travel time. Again, right now we don't have paths volumes loaded in, so the volumes are all zeroed out. But you can see if we have any toll sections and things like that. Similarly, we could look at the public transportation systems. We can see information about these different public transportations: bus, rapid transit, circular, local bus, LRT, project buses, and things like that. Walking, public transit walking. I also want to point you to the user-defined attributes. So these attributes there are a lot of them that have been imported from the previous older versions of the models. But the big ones I want to point out that we're going to be using in the future are area type and facility type. And the reason I want to point out these two to you is because when we build new links in these models, if you put in the area type and facility type, then we have procedures that will fill in all of the rest of the information. So the big things that we're going to have to worry about is, do we have the right number of lanes? Do we have the correct area type labeled and the correct facility type number labeled? And by adding those three things, the procedure will fill in the capacities and the speeds and everything else for us, so automatically. So you don't have to go out and fill in all this information on your own. And we'll see that in our example tomorrow when we go out and we build in a new build. We're going to just be assigning area types and facility types and then the number of lanes. But this is where at an individual link level, we can go look at specific data. You can also click opposite and that will switch the direction. And so now we can see the southbound direction. So you can see the values for the southbound direction. Now, some links are going to be one-way links. So these might be on-ramps or off-ramps or freeways. So for example, we have this freeway 275 here. If I double click on this one, you can see that I'm hovering over the bottom side. And the reason I'm hovering over the bottom side is because that'll put me to the right of the link if I'm looking down the direction of travel. So we can see this is the eastbound movement. If I double click on the eastbound movement, you can see it's labeled as a freeway or an expressway. We can see what types of transportation systems are allowed to run on it. We can see its speed, its lanes, and its capacity, as well as under user-defined attributes, its area type, and its facility type. One thing I want to point out, or that you might have noticed though, is that you see these values are yellow. And the reason these values are yellow is because if I click the opposite direction, these are all zeroed out. And the reason these are zeroed out is because we have modeled this freeway segment, since it's a divided freeway, as two separate links. So we have the eastbound movement here and we have the westbound movement here. Now in Visum, every link always has two directions. So if you have a one-way link, the opposite direction of travel will just have 0 lanes and 0 transportation systems allowed on it. And then type 00 there. So in this case, by filling out area type 0, facility type 0, and 0 lanes, it'll essentially close that link for the opposite direction for us. So looking around, you can see what types of information we have. So for example, here's what an interchange might look like. We have the off-ramp here. And if I click in the opposite direction, you see how it's thin? That's because it has no lanes in that direction. Versus if I have a 2-lane link, it's going to be thick in both directions. Here we have lanes going eastbound, no lanes going westbound. So we can see here we have the on-ramp, but the opposite direction of the on-ramp is turned off, and then we have the off-ramp coming here. And so this is how we would build out certain interchanges. Versus some intersections, like this one, are just going to have links approaching to it. And yes, they might have right turn pockets, but that can be defined at the node level. So you can come into the node and define turn pockets. But for something like a freeway element, you're probably going to be modeling the actual curvature of the links themselves. Or if the turn pocket's really big, you might do that, or sometimes roundabouts or circulators and things like that, you might do that. We can also define graphic parameters for the links based on, right now we have a uniform display, but you can always switch it over to a classified display and based on different attributes. So we can pick out type number or something like that. We can classify the different links based on type number or facility type or area type. So that way you can more easily see what the different links are rather than having to click on each one and observe their values. You can create a graphic overlay that will do that. So if we come into graphics and go to display, switch over to classified display, and then hit preview, we can see that we can see all the different links based on their link types, right? Now, what are these colors? Here we have a legend up in the corner. If I left click on this legend button, everything's popping over onto the side. I can put in link information, preview, and click OK. And so here we can see link type number here. So this is link type number 10, 20, 30, 40 with the different colors. But that means that you're going to have to remember what those link types are. So you could always come back in and change these to different values if you wanted to. So for example, if I look at this blue link, it's a divided arterial. So in our 20s, those are all divided arterials. So if I come back to graphic parameters, display, the 20s right here is going to be, sorry, where's my name? Legend name. This is going to be divided arterial. Click OK. And that will update my graphic parameter or my legend up in the corner. So again, you can always make your life a little bit easier if you're in, say, for example, a review capacity. You can go look through this at a graphic level and it makes it a little bit easier than having to click on all the objects or looking at the link list, which might have, you know, thousands and thousands, 24,000 links, and checking every single transportation system set. So that's the links. All right. Adam, I just really quickly wanted to see before I move on to zones, since we kind of went through that a little quickly, I wanted to see if there was any pertinent questions about links and nodes before I moved on to zones and connectors.
I think the one thing that I saw pop up, somebody asked about like acceleration lanes, which you kind of covered, but I guess you want to just explain real quick how those like acceleration lanes are handled, or like pocket turn lanes.
Yeah, so in that case, if we're looking at something like a freeway with an acceleration lane, I'm going to turn off my legend real quick. It depends on how you want to do it and what level of detail you're going into. But at this macro scale, what you'll probably do is you'll have the merge point here. So you'll have a node representing the actual point at which the acceleration lane starts. And then for that weaving section, you could have a segment of link. So you'd have another node downstream that represents the end of that auxiliary lane. And then in between those two nodes, you'll have a link with an extra lane for that short section. If you're doing something a little bit more detailed, like simulation-based assignment or other types of assignment that might be a little bit more lane-based, then what you can do is actually just at the node, you can add a turn pocket, right? And so you would have an acceleration lane representing as an exit pocket in the Junction Editor. So you could come into this node here, and the geometry is a little funky here. Something's going on funky with this geometry. I'm gonna undo that. Oh, where am I? I'm over here. Sorry, I got a window. No. So here at this node, you could always just enter a turn pocket if you're gonna go to the node geometry level. In this case, we didn't put in that much detail because we're keeping it at more of a macro scale. But so there's a couple ways you can add in auxiliary lanes depending on what level of detail you wanted to go into, either as an exit pocket on the node itself, or more commonly what people will do is they'll say, okay, this is a 4-lane section, and then there's a node that drops back down to a 3-lane section. And either one of those ways is acceptable.
Okay,
And then,
okay.
okay. Oh, and I was going to say the opposite works just as well for exit lanes as well. So if you have an exit lane at the node, you could put a turn pocket, or you could just have add an extra lane to that link leading up to it. That is the length of the turn pocket.
Okay, thank you. And one other quick one. Is there a way to just like keep those directional arrows on all the time if you want to be able to see that easily without clicking on it?
Well, each link has both directions at all times. So it's kind of tricky to determine if to have them on, because then you just have 2 arrows pointed in both. It would look like this everywhere. No, don't do that. Try to do. It would kind of look like this all the time on every link, because every link has 2 directions of arrows. Now, what you could do is, again, define them as the different link types, like what we've done here, and then they will show via color, and then you can also go into the graphic parameters and adjust what that shape looks like a little bit. But I don't think that there's a way to have, for like a one-way link, to show that it's only going to the left or to the right.
Okay, great. I think you can go ahead and move on.
Sorry, everybody. So there is a way to do it apparently somehow. So I'm getting a quick one-way roads. Okay. Okay. So for one-way roads, we do have a button for specifically one-way roads, but not all links. So here you could see one-way roads in the graphic parameters. So again, go into your link graphic parameters display. We have active, which are all the links that are active in your network. Passive are ones that you haven't selected. Marked are the ones that you've physically clicked on. And then specifically for one-way roads, you can define what that road color is and what it would look like, whether it's a triangle or square or circle or something like that. All right, cool. All right, so jumping into the next set of objects, we have our zones. Zones act as demand generators and attractors. And in Visum, you can represent a zone as a single point, or you can have it represented as a spatial area. Looking in the zones list, you can see that the zones have different types of attributes stored. So maybe something like population or school enrollment or employment data. In our particular model that we're looking at, there's going to be a lot of different subcategories. Now, I know that we had a question in the first, just before the break, asking about, do we need to keep zone numbers the same from one scenario to the next? And the answer is yes. If you want to compare those zones together, then they need to have the same ID, because Visum uses this node number attribute as the comparison attribute to identify which zones to compare. But if a zone ID, for example, is changing its TAZ number, we have a specific attribute called TAZ area And there's another attribute for TAZ number, and you can go and just change that value. So that within Visum, the structural ID stays the same, but maybe you split it up. And you can have like an attribute that says old TAZ number, right? And you can do lookup tables and things like that. So using user-defined attributes, you can keep the data even though some of the IDs might change and things like that, but still be able to compare the two as long as the actual numbers themselves don't change. All right, so jumping into Visum, I'm going to deactivate the links. I'm going to turn on the zones and kind of zoom out. So here we have all of the zones within the model, and right now they're showing the various zone ID numbers as well. So what I'm going to do is I'm just going to turn off the point object, which is the ID number, so we can just see the spatial boundaries of the different zones. So each one of these zones represents a space that creates or attracts demand, and then the matrices pull the demand from these zones. So as we zoom in on somewhere like downtown, obviously the zones are going to get smaller, but these are all the zones that we have here, and they can be pulled from shape files. You can also manually edit them. So if you click on a zone, if you right click on it, you can say permit interactive editing, and you can edit the points of the zone. It's not super common to manually edit the shape of the zones. Typically, they'll be imported or something like that from a shape file, and then you can adjust from there. But you could always break up or combine different zones together as well. So each zone is going to generate and attract demand, and then each zone has a connector that goes from the centroid to the node network. So if I activate my nodes, you can see that there's a connector going from the zone to the connector, or to the nodes. And zones can have multiple connectors depending on what access there is to that zone. And so for this sake, we don't necessarily need zones to be down to the block by block level. They can be neighborhood level or county level. Just depends on what level of detail you are going into. And what level of demand is being generated. Like when we get into downtown, they're fairly small and tight in, but as we get farther and farther out, they get bigger and bigger. Okay. The zones themselves, if I open up the list, let's take a look at that zones list. So here we have I'm going to put it off to the side just so we can compare the two. We have various types of attributes associated with each of the zones. And a lot of these are going to be for the demand generation side and demand attraction side. But there are some of them that you'll actually update for various purposes. Like, for example, we have dwelling units. So you can specify the number of dwelling units within a place. Some of these are also calculated. Employment, enrollment values, things like that. And we have list layouts that allow us to more easily work with some of these. So you can see various zone layouts, zone data. We also have some pre-built ones for the training, such as demand. Oop, where'd you go? This thing got huge for some reason. Okay. So here, for the training purposes, we created one that just highlights a couple of the important ones like population, K-12 enrollment, total employment, total population, and then dwelling units. So here we could go through, and we'll do this tomorrow, go through and you can do zone updates based on this data. Now, sometimes this is manual. A lot of times it's going to be updated through some other mechanisms, whether it's import exports, scripts, things like that. One thing I want to show you at this point though is that you can filter these lists. So for example, if you have some criteria like TAZ area, maybe you want to filter this by a certain value. So if you hover at the top of the list, you see we have this little filter button. If I click on that, I can say, okay, I only want to see values that are larger than, in this case, it's TZ area, so I'm going to type in 200. And what this will do is this will pull up all of the zones that are larger than 200. And so this will allow you to filter the data for different perspectives. So maybe you need to grab all of the zones that meet certain criteria and then mass edit them. For example, maybe I turn this off and you want to find all of the zones that has a non-zero enrollment, and you want to see all the zones that have non-zero enrollment. So here we can filter out, and we have 616 zones that have some sort of K-12 enrollment versus 3,000 zones that do have enrollment or that are total. Oops. So in this case, you can apply filters and then you can mass edit these. So maybe you want to increase enrollment across the board, but just on the zones that already have enrollment. Well, now you have these filtered out, you can grab them all and then apply growth factors to them or adjustments to them as needed, calculations upon them. And so applying these filters is pretty straightforward. You can do it in the list. You can also right click on the zones list here and you can create a filter in the zone itself. So if I right click on zones and select filter, I can do the same operations. So I can find the attribute, and I'm going to call it K12. So I'm going to filter by this attribute. I'm going to say, okay, I want to filter for any values between, and I want to say maybe between 100 and 300, right? And when I click OK, this will only highlight the zones that are between those two factors. And I need to update my graphic parameters so that the passive doesn't show the point object. And so here we can see all the zones in the network that are highlighted in blue. These are all the zones that have K-12 enrollment somewhere between 100 and 300 enrollment value, right? So you can pick and choose which zones you want by applying filters. And we can see the filter button is on, and I can just turn off that filter there. And again, to get to this, you can right click and select filter, and then you can define whatever you want that filter to be. You can have multiple filters that you can pick between. And then you can also save those filter files as .fil files. So just 1 second. Let me see if this thing is still huge. It is. I don't know why my thing got really big for some reason. I'm not sure why. So I'm trying to shrink it down. Oh, that's too hard. I just killed it. Okay. Let me do this. Close all windows. All right. And then I could just do this. File, open file, and I'm going to open a filter file. So we have a whole list of filters that you can pull in for various reasons. And so let's say we wanted to activate our filter for our school enrollment. Well, you can take this filter and you can save it. So you can save it as a new filter file. I'm going to call this K12. I'm going to say underscore zone. And I'm going to click OK. Where is it going? Check. There we go. Click OK. And so now when I hit open file filters, I can see a K12 zone filter file right here. So if you ever need to load this up again, you could always reload that in other scenarios or something like that. So again, filtering allows you to pick and choose what objects you want to edit in mass. So if we apply a filter to the list, we can come through and edit them. Similarly, the next step we can take beyond that is what you'll see is in the procedure sequence. In some of these steps, you'll see different filter options. I don't have one off the top of my head. But you can read, there's an attribute that says, or a thing that says run filter. read filter right here. So you can always filter in and then have the procedure sequence run through a script to import, for example, maybe you have a Python script that imports zone data, right? But you only want it to import into specific zone types. So you read the filter in and you select that filter file, and then you run a Python script that will then update those zones accordingly. So you can totally automate this process so you don't have to go through and manually update all of your zones. All right. So the next object I wanted to touch on was the transit stops and transit model structure. So here, just like with nodes, we have transit stops that define where public transit vehicles are going to stop and mode shifts can happen from, for example, maybe a trip starts as a walking trip and then they walk to a bus stop and then they get on and they are now a PUT trip on a PUT vehicle, right? And so these stops act as those changeover points as well. A stop can be, it doesn't have to be a physical bus stop. It could be a transit center. It could be a park and ride. It could be a curbside pickup. It could be various objects. Once we have the stops in place, we then overlay transit lines that then service these stops. And we're going to have an opportunity to build out a new transit line in tomorrow's session. But the transit lines define the names, the routes, and the network, vehicle headways, as well as ridership fares. So within these line routes, you'll be able to build out not only the course that they take, but how frequently do they pass through, and what is the cost of taking that vehicle. So that way, when a trip is making a decision in their mode choice, they can factor in how much will it cost to ride public transit. Okay, so let me jump over into Visum. I'm going to turn off the zone structure and I'm going to scroll down until we find the stops. I'm going to activate the stops. Now, we've already brought in the public transit data. So we have the public transit stops here, and then we also have the public transit lines. So you can see the various lines that are servicing the different stops. If you select the lines, you can then come in and look at the different lines and line routes that we have and see their different names, what their fare system is, what transportation system are they using, so what mode of transportation are they? Are they a local bus? Are they an express? Are they a BRT or an LRT? And so you can assign the lines to the network here, and different lines can have different line routes. So you might have a line route that goes westbound and then a line route that goes eastbound. Or maybe you have a line route that's a circle and you have one route that's going clockwise and one that's going counterclockwise. You can also have different line routes for different times of day. And then in addition to the public transit stops and public transit lines, we also have public transit operators. So in the network section, you'll have public transit operators. Everything comes onto that screen. So we can see the different operators here. We have the Hillsborough area, we have Pasco County and things like that, Citrus County. And within each one of these, we have a fare system and everything like that. So you can assign fares at either the line level or at the public transit operator level. And again, to get to public transit operators, it's in the network under PUT operators. Okay. So once we have our physical network set up, we have our nodes in place, we've put in our links, we've put in our zones, and then we've connected the zones to the nodes with connectors, and then we've put in our public transit stops and our public transit lines. Now comes the point when we need to assign demand to the matrix or to the network. And we do that through matrices. So each one of the zones that we talked about has a certain production rate or an attraction rate. And those would be the total inbound and total outbound trips coming in and out of that zone. But through things like distribution, through, you do your demand generation, your demand distribution. Through the distribution, you're going to take those totals and you're going to distribute them to all the other zones in the network in some proportions. And that's done at the matrix level. And we have two main types of matrices. The two primary types of matrices that we have are demand matrices and skim matrices. Demand matrices represent the matrices that store trip data, and these can be at various levels. So you might have specific demand matrices for a time of day, or specific demand matrix for a specific mode. So for example, if we look here, we have demand matrix number 42, that's SOV AM versus SOV midday, right? And so you can create multiple different demand matrices and then combine them and group them together as needed. The other type of matrix we have are skim matrices, and these are matrices that store OD data for purposes of running assignments or collecting output data. They can collect things like impedance or travel time or average trip length. So you can see within these different skim matrices, what is the level of travel time that was, or delay that was, impedance that was experienced by SOV vehicles between zone 1 and zone 5. And then you can also look at HOV impedance and things like that. And so you can utilize these skim matrices as part of your assignment process in some sort of iterative loop, or as a final output as well. When looking at the matrix, there is a matrix editor that we can look at. So if we double click on a specific matrix in the matrix panel, it'll open up this matrix editor. And within the matrix editor, it's going to look the same whether it's a skim matrix or a demand matrix. But what you're going to see is you're going to see all of the zones that we inputted into the network as rows and columns. And the rows represent the origins and the columns represent the destination zones. And then you can see that they have a sum value in green at the start of every row and at the top of every column. And then those yellow boxes are just the boxes representing the diagonal, meaning, going from zone 1 to zone 1, right? So in that case, if you have some sort of activity-based model or something like that, they may end up at the end back at where they started from. But here you can see we have different values within each one of the cells. If we click on one of those values in the cell, it will actually be mapped over to the network editor, so you can actually see which zones it's referencing in the network. So if you want to click on one of them, you can do that. Now, you can fill these in manually. You can go in and fill in these cells, but you'll notice, for example, that our matrix number 42 is 3,000 cells by 3,000 cells. So that's, huge order magnitude. Was that 6 figures, 7 figures of cells that you don't want to edit on your own? So a lot of times what we're going to do is we're going to be doing some sort of either import value, where you're going to be importing data from various types of matrices, or you're going to be applying different matrix operations to the matrix itself. So in this case, what we've done is we've applied a growth formula. So there's a button up at the top that shows a multiplier. We can click that and we can multiply by a certain value. In this case, we're taking this matrix number 36 and multiplying it by 1.03, and that will uniformly scale up every cell in the matrix. But you can also do a combination of matrices. So for example, let's say we have asymmetric growth, right? Some of the zone pairs are going to grow at a certain rate and other cells are not going to grow at that rate. So what you can do is you can create different matrices that represent specific zone pairs, and then you can multiply those by that growth factor and then add it to another matrix, right? So you can combine multiple matrices together to generate a larger and larger matrix. In this case, this example, what we're showing is we take matrix 36 and we're adding 2 to every cell in that, and then we're going to multiply, or sorry, we're adding 36 to matrix 37 that has a factor of 2 multiplied by it. So we're taking matrix 37, multiplying it by 2, and adding it to matrix 36 to combine them together. So matrix 37 might not be fully filled out. There might be a bunch of zeros in there, and only the cells that we want growth to happen have a non-zero value. And what we'll see is that there's a lot of these calculations going on in our procedure sequence. So if I jump into Visum, I'm going to deactivate my public transit line and my stops. I'm going to reactivate zones just so we can see the zones. So what we can do is behind the network objects on the side here, there's a tab for matrices. So if I click on that, we can see we have our demand matrices and our skim matrices. So if I expand demand matrices, we have a bunch of demand matrices in here, all for various purposes in the procedure sequence, which I'll get to in a little bit. But let's take that matrix number 42, for example. If I double click on matrix number 42, you just shrink it down a bit so it's a little bit easier to use. We have our matrix right here. I can see that in this case it's zeroed out because we haven't run any of the procedure sequence yet, and a lot of the procedure is going to be building out these matrices. But if I click on a specific pair of cells, you can see that it's linking, okay, here's that OD pair, number 5 and number 7. So this would be a number of trips going from 5 to 7. Well, what we can do is we can apply different operations to this matrix. So up at the top of it, you can see that we can add a value, we can subtract a value, we can multiply. So if I click one of these operands, in this case, I'm multiplying, we can multiply it by a different matrix. So I can multiply it by matrix number 43 if I wanted to, or I can give it a constant value. Maybe I want to give it a growth value. So I might type in 1.03. So this allows us to apply different operations to the matrix directly if we wanted to. We can also come into the procedure sequence and we can create a matrix step called combination of matrices and vectors. And what this procedure step will do is this will automate that process. So just like what we did in there where we went and we hit the multiply button and we say we want to multiply number 42 and number 43 together, we can add in our own procedure step. Where is matrices, combination of matrices and vectors. So we add in a procedure step called combination matrices and vectors. And we can just say, okay, I want to take matrix number 42 and I want to multiply it by matrix number 43. Right, and so we can automate that process, and we've actually done that in a lot of these previous steps. So here we see a combination of matrices and vectors in this mode choice section, right? So we're taking some of these matrices, combining them together in different formulas. So in that case, if you're doing any sort of population synthesization or anything like that, you can do that, or mode choice or assignment. You can pre-combine all these matrices together and then get a final matrix that is then assigned to the network. So if you're worried about having to build out all these matrices by yourself, a lot of the times these are imported or they are generated through the procedure sequence. All right, so once we have those demand matrices generated, now we need to assign them to various modes. And so here what we're going to look at next is in the demand menu, what type of modes are we going to put into our network? So if the zones define the population and land use data, matrices define the number of trips going between those zones, and then the demand data defines what modes of transportation they're taking. And in this case, the modes that we have are, or the transportations we have combine together to create a mode. So for example, this kiss and ride mode of transportation might have something like a bus rapid transit, circulator, local bus, LRT, walk to transit. So modes combine multiple different transport systems together. And then we take those modes and we combine those modes into demand segments, right? So if you have different modes that represent something like park and ride and kiss and ride, those would all be combined together into some sort of transit trip, right? And so in that case, you might have some SOVs that lead to a park and ride, and then those mode trips switch over to a transit trip. And then it's the demand segments. So again, you have the transport systems that are grouped into modes, and then the modes are grouped into demand segments. And then it's the demand segments that are paired with a matrix. So once we have, again, we have those zones generating the demand, and then we have the matrices distributing that demand, and then we have that demand being assigned by demand segment. So of all those trips that are going between those zones, what types of trips are they? Are they public transit? Are they single occupant? Are they heavy occupant? Are they truck transit? And so in the demand segment, we assign a matrix to those profiles. And then all of this is then actually assigned to the network via the procedure sequence. So before I get into the procedure sequence, let's take a look at our demand. So we have the demand up here. We have transport systems, modes, and demand segments. So the first one I'm going to look at are these transport systems. What transport systems do we have in the network? Now we've seen the word transport systems before, and what happens is these transport systems are allowed or disallowed from using links or turns or nodes. And so where we've seen them before is on the link editor, right? We saw transport systems. And so you can allow or disallow different transport systems from using a particular link. Well, then those transport systems are then grouped together into modes of transportation. And then those modes are grouped together into demand segments. And you can see what modes and transportation systems are assigned to each one. Once you have your demand segment, you come into your demand data. And the demand data, it takes its demand segments, and then it assigns a matrix and a time series to that demand segment. So here we see HOV is being assigned matrix number 59. If we look over here, matrix number 59 is HOV current. SOV is being assigned matrix number 58, SOV current. So you might have different SOV or HOV matrices that are all compiled together to give you this final demand assignment matrix. Here we see matrix number 60, which is truck current. Matrix number 55 is transit walk off peak. 54, transit walk peak. So once we have, again, we have our zones, which have some sort of demand generation and attraction data. Then we have the matrices, which are distributing that data. And then we have our demand segments, which are being assigned to those matrices. And then the final step here is we come into the assignment, and all these other steps are doing different things like calculating skims to update the impedance values or update mode choice values and things like that. But the final step is the network assignment step, which is taking a mode or a demand segment and it's assigning that demand segment to the network for a given time of day. And here we're just kind of going through the different procedure steps. So we have trip generation being done. This is mostly done through scripts. And then we have the trip distribution between zones. Again, we have some scripts doing that, but we also have some trip distribution steps in there doing that. Then we have our mode choice being done. So we have some nested demand and then some scripts that update some values in the network and then combination of matrices and vectors. And then finally, we have the assignment section, which is actually taking those final matrices that are done from the trip generation, trip distribution, and mode choice, and those are being assigned to the network as needed. Now, if you want to add more detail to the network, you can always add in things like signal control and things like that. If you wanted to go down to like a mesoscopic assignment, you could always add in more geometry, do something like a simulation-based assignment.